Hello and welcome to another CS200 mini lecture. Today we're going to talk about Chapter 10, Memory Management. We'll finish up the chapter and we'll talk about 10.4, 10.5, and 10.6. 10.4 and 10.5 specifically refer to garbage collection, and 10.6 is an example of array lists. So let's get started. So what is garbage collection exactly? Sometimes it's abbreviated GC because it's such an important aspect of a programming language. Some programming languages don't have garbage collection, but Java does. So what it does is it uses a mechanism, think about it as overhead inside the program or the virtual machine, that looks at memory that's been allocated in the heap and sees if that memory or the variables that are using that memory are still being referenced by any aspect of our program. If it's no longer reachable, in other words, there's no references to it, then what happens is it sets it for garbage collection, which means it's freed up for other processes or other aspects of our program. In other words, we can use that memory space again. This is important because the heap is only so large. So this gives the ability for us to use more memory for our programs because we can use it again and again and reuse it. So what Java does is it looks and maintains a reference count. And if that reference count is 0, then we consider the object as unreachable and then set up for automatic garbage collection. So let's take a look at this example. So initially what happens is we declare an integer object. Notice I said the word object, and notice it's using the capital I integer. And we set that equal to null. We know this is not just a simple integer of a primitive data type because we wouldn't be able to set it to null. And then we also set another integer data type to null as well. So we've declared those. And what happens is on the stack, they're just given a value of null. In the next step, we're allocating some memory for that integer object and assigning myInt with a reference to that memory location. So you can see that on the stack, the memory location, the reference is 9400. And inside that integer object, we store a value of 10. So we also update the reference count. We call it ref count here, and that's set to 1. It's not actually occupying any of the memory in heap. It's maintained by the Java virtual engine. So then we have our other integer with a capital I, which is an object, and that's signed with a reference to the same integer object's memory location. So why is this important? Because if we declared some other memory, other value for it, we didn't just say myOtherInt equals myInt, but we said myOtherInt equals 10, for example, then we'd have two objects in the heap, each with a ref count of 1. But because we've set them myOtherInt equals myInt, we're actually referring to the same memory location in the heap. So the reference count is updated to 2. Next, we take our original integer and we set that to null. But remember, myOtherInt is still pointing to that memory location of 9400 and the object contained within. So this decrements the ref count to 1. And now when we set myOtherInt equal to null, there are no pointers to that area of the heap. So the ref count is 0, and that area is set up for garbage collection. So we can deallocate that memory. We don't have to specifically do anything. Java handles this for us. So when we have different variable scopes, remember we talked about this in chapter 8, the scope of a variable is important as well. So when we no longer have a variable within scope, it's also marked for deallocation. Let's take a look. Now there's a couple steps in here, so we need to see here what's going on. So remember our main is below, and what's happened is we've set num bits, that's our integer value, a primitive data type integer, equal to count bits, which is our method, and we're passing it an argument of 7. So there's a method call, and that calls count bits up top. When we get to count bits, it takes the parameter and sets it to innum, and also declares two other local variables, count int and binary str string. So what happens on the stack is num bits is set to 0, right? So it's waiting for a return call from this method. And then because it's been initialized, that's how it gets the value 0. Then we also initialize count int and binary string, and we say binary string equals integer, and then we have this conversion method that takes the innum, which is 7, and converts it to a string object, and that's placed on the heap. So it's 2 binary strings, so that's why it converts it to a string, and it converts 7 to the value 111, which is 7 in binary. A lot to that step. So next, we have count int, which is looking at the length, and the length of that is set to 3. Let's go through that step again because it was fast. So that's passed into count int. Now we return to main, and then num bits equals count bits, and that value is passed back, the 3. Remember, because that's what we returned from the count byte method. And because there's no more references to that string, that's marked for deallocation. You might want to go through this example a couple times on your own, just because there's a lot to it and it moves fast, but I like how this animation helps. So now with garbage collection, it's a nice feature of Java, but one of the negative things about it is Java takes some time to manage all this, and it requires some overhead in terms of space and in terms of time. Other languages like C++ and C don't have garbage collection. That's the responsibility of the programmer. So when we allocate memory in C, for example, we have to issue an alloc or a malloc, which are commands, and the programmer is responsible for allocating memory and also freeing it up at the end. Because it's kind of close to the metal or a very low-level language, and Java is a little bit more of a higher level, it's got some additional overhead that would not be present in C or C++. Let's take a look at this example of array lists. Now, this is an example where they ask you to complete it. So here is the template, and then they have the final answer. Well, I have the final answer. So let's go to our friend BlueJ and take a look at it. Again, it's using array lists, but I'd rather do it in BlueJ than in this. So this is actually a full program. And the nice thing about it is we can actually run it and see it work. And it does use a lot of the aspects of array lists. So if you're not familiar or comfortable with them, I'll put this program out online so you can play around with it. First of all, we have to import array list. We also have to import the scanner object because we'll be reading in information from the screen. So in the public class memory management, let's go down to main. Okay, so here is our main. And the important thing about main is first of all, it has a prompt action. So we just have a string that we're going to repeat over and over again. Notice we use the keyword final for the first 3 variables. This means that they will be put into the static memory portion of our program, or into memory. So remember, we have the code portion, we have the static variables, then we have the heap and the stack. So we have 4 different areas. When we declare something as final, we know it's not going to change. And because of that, it's put on the static memory, or it's memory that won't change through the life of our program. Then we declare 3 different array lists. And you may wonder why 3 different ones? Why not just one? Because when we add information to one, we can keep the element or the index the same because we'll be adding to each one at the same time and deleting from each one from the same time. So the index will give us the ability to delete. Okay, so the rest of main, we do a get action, which all that does is prompt for what we want to do in terms of information. We'll see that in a minute. So then we have while user action does not equal the exit code, and remember the exit code is set. Exit code is X. So notice we can just change that in one location. So A, D, and L, and notice they're in uppercase. So those are our 4 choices, and then we just get the prompt. So add employee is one of the 4 choices we have. And when we add an employee, notice what we're getting is we're getting these 3. We have 3 parameters, each of the 3 array lists that we're managing. And notice that it's void. So we're not actually returning anything. So we declare 3 objects, the string object, and notice we put the, so the name, the department, the title. This keeps it from us from getting confused between the name of the array list and the actual string object. So we ask what is the name to add, and then we ask for their department, and notice we're using their name specifically. And then we're also asking for the title of that person. Then we add it to the 3 different array lists, and then we output some information as a confirmation message that it's been done. Delete kind of works the same way, except for, and this is the part that they're asking you to build, but of course we can look at this just as if it was part of the original program. Again, what we're passing in are 3 different array lists, and then we have returning nothing because all we're doing is we're updating the array list. So that is an object, so we don't have to pass it by value. We declare 2 integers. One is number of elements, and then the other one is element. So notice how we can get the size of the array list. Because all 3 of them are the same size, we just pick name, which is one of those 3 array lists, and we use the method size. Okay, so this is built in. This just returns, it's much like length. So if there's nothing in there, then it's greater than 0, then what that tells us is we have something to delete. And we would give them a range of 0 through, and if the number of elements say there's 2, we'd have a choice of 0 and 1. And then they have the option of -1 to skip the deletion. Okay. So if the element entered is greater or equal to 0, meaning they don't want to skip, then we have a remove method that's built in for array lists that allows us to remove a specific element. So this is the index of the array list that we want to remove. Then we give a confirmation message, and if not, then we say there's no more entries to delete. So that's what we get if there are no entries for us to delete. Moving forward, we do list employees. So this just prints out all the elements in each of the 3 array lists. And again, we use the size method, and we use it on the main, but this is arbitrary. We could pick department or title because all 3 are the same size. If it's greater than 0, in other words, we have at least 1 element in the array list, then we print a line just to give us some space, and then we do a loop. Notice we do this by using the get. So we print line, and then we use name get, and then because we're in a loop, I increments each time we output a specific value from each of the 3 array lists. Otherwise, we give a message saying there's nothing to list. And then here's the get action. Get action is very simple. And what it does is it just reads in a string object as an answer, or just a string as an answer. And then we get the first character. And because we need to have more than one character, what we do is we say answer equals next line to uppercase. So this avoids the problem of somebody typing a lowercase a or an uppercase a. We convert it all to uppercase and compare against that. And then we have a space. And that just basically ensures that we have at least one character, even if the user typed nothing. Because if they typed nothing and we got a null here, we'd get unexpected behavior. So all we're doing is we're taking the first character anyway. So appending a space onto if they typed in one of the values, that's not a problem, because we're just taking the first character, but we're avoiding the situation where they type nothing. And then we return the first character, which we evaluate in the game. So let's take a look and see how this runs. It's called memory management. I've already compiled it. I haven't changed anything. So let's take a look. So here we have our program. And we do a list just to see we have nothing in there. So now we add a value, Joe Schmo. And he's in accounting. And he's a manager. I'll be right with you. And then we add another value. He's in IT. He's a manager. And then one more. Red. He's in IT. And he's assistant manager. And then we can show a list. And we can see all 3. And notice they're putting in the order that they were put in. So then I can choose to delete one. I'm going to choose delete one. And if I list it, I can see this. The one that was in the middle is removed. Okay, so I hope this is helpful. And I invite you to play around with this program. And I will answer any questions you have about it. So this concludes chapter 10, and I will be back with you with chapter 11. Thank you.